Hello, my name is Alex Nasser, and today I will be looking at failing floodplains, suggestions for rewilding areas of vulnerable wetlands in Houston. My first journal article was published way back in 1997. William Michener looked at how climate change is associated with hurricanes. He looked at the way that the intensity, frequency, and distribution of hurricanes will increase because of climate change. Hurricanes and climate change will affect our natural landscapes, which can in turn affect community structure, natural selection, extinction rates, and biodiversity. Natural selection and biodiversity are markers for future landscapes because without these, our ecosystems will not function. In the paper, Texas was also found to have the second highest number of hurricanes, with 50% classified as 3 to 5 category storms. Also, in reference to biodiversity, this paper looked at how mangrove forests in Florida were wiped out as a result of hurricanes. Mangrove forests are essential for biodiversity and ecosystem function. For the solutions, the paper was fairly vague due to being written almost 20 years ago. The authors stated that we need to bring science together to understand linkages in nature. B. L. Turner II and his researchers looked at the emergence of land change science for global environmental change and sustainability. Their findings included that 50% of Earth's surface has been transformed, and this is without taking into account areas that are covered with ice. 40% of land is dedicated to agriculture, some of which emit harmful methane gases. Since we've transformed 50% of the land, this affects the global environment in a negative way. The possible solutions look towards land change science and satellite data to study the effects and foster scientific solutions. In 2010, an article was published that focused on how forest cover change affected an area in Vietnam from 1989 to 2008. Researchers found that floods in Vietnam were associated with decreased forest cover, which then the forest was not there to absorb the floodwaters. Instead, on pavement, the water would keep flowing. People living in the floodplains were far more susceptible to flood damage. The reason that forests were degraded was because there were significant wars happening. People were moving outward from the city, cultural practices were using forest land, and the government wasn't doing anything to protect the forests. This brings us to how climate change and land cover change has affected one vulnerable city, Houston. Houston experienced floods on Tax Day and Memorial Day that killed 16 people and caused over $1 billion in damage. This wouldn't have been a problem if Houston hadn't experienced a massive urban sprawl and also effects from climate change and clearing forests. Political difference also arose in what to protect and how to assist citizens. Here's a picture that captures what FEMA designated as floodplains and where floods actually were. Hurricane Harvey was a catastrophic disaster that poured over 9 trillion gallons of water and 9 inches of rain into the city. This article talked about how the real issue with flooding was that once the water was in these low-lying areas, it had no way to get out. Paving the sponge is a huge debate over whether this is a cause of the floods. Paved areas include roads, parking lots, sidewalks, asphalt, concrete, brick, and stone. They are also considered impervious because water cannot penetrate through them. The solution is that we need to design and build cities around areas that can absorb all of the water. Another article focused again on the impacts of flooding in areas around Houston due to Hurricane Harvey. This article looked at an area around the Katy Prairies. It is found that over the past 30 years, development has come in contact with floodplains. These types of development have not included sufficient areas of grass for water to absorb, nor did they improve drainage following a massive flood. FEMA has been an organization talked about a lot because they are the governing body that designates areas as floodplains. Areas outside the floodplain were as damaged as areas inside the floodplain, which raises questions about FEMA's designation as a floodplain. FEMA also doesn't receive a lot of backing from Congress, so they're unable to fund mapping initiatives regularly. The same idea that keeps popping up in this debate is that the population increase resulted in taking away natural areas that kept water from flooding cities. From the article, we can see a change from 2002 to 2016 in high development areas outside Houston. As you can see, green spaces were paved due to a population increase outward. My research focuses on how we can first assess FEMA's designation as floodplains. I then create my own floodplain data in two areas of vulnerability. One, surge vulnerability, and two, rain vulnerability. I then overlay this data with FEMA's 100-year floodplain in areas that were actually flooded by Harvey. My suggestions include areas for conservation and how we can mitigate flooded areas. We can see that forest cover change in Houston has been reduced by almost 50% from 1992 to 2011. Population has also increased outward at a rate of 50% from 1990 to 2010. In red are areas designated by FEMA as a 1% annual flood chance, or in other words, the 100-year floodplain. We can see that there are areas that are blue that were actually flooded, which do not line up with areas that FEMA designated as a floodplain. This was overlaid on top of relative elevation that shows low-lying areas. Relative elevation shows us rain surge vulnerability. Through focal statistics and raster calculator, we can see areas that are low are also vulnerable areas in Houston. Looking at this further, I overlaid areas in Houston that were actually flooded by water. Is there a disconnect between areas that are flooded and areas designated as floodplains by FEMA? The answer is yes. Using GIS, I also mapped areas that were close to water and low in elevation. We can see that these can be designated as vulnerable areas because water will collect heavily in these areas. I also looked at areas that are impervious. Black areas show where if water hits the ground, it will penetrate the surface. Red and purple areas are essentially roads and where water will flow once it hits the surface. Relative elevation, again, gives us clear insights on rain surge vulnerability areas. Areas that are low are highlighted in red, and these are the most vulnerable areas to floods. I also mapped where these near water, low-lying areas are also near impervious pavement. Impervious areas are vulnerable also due to water hitting the surface and flowing elsewhere, rather than the black pervious areas that absorb water directly. This is my final map and shows where we can do conservation of rewilding and depaving roads. This brings us to the conclusions. Areas near water, low elevation, and impervious show vulnerability to storm surges. Areas in low relative elevation show vulnerability to rain surges. FEMA's 100-year floodplain model does not represent areas that are in need of rewilding. Instead, these represent areas where the sponge was paved. In my previous map, I show where areas of rewilding are needed to be done. Also, in my research and in looking at FEMA's 100-year floodplain, I also saw that it is difficult to model floodplains in areas of high risk. This leads us to possible solutions to flooding as a result of paving the sponge. One article dictates permeable pavement as a solution to flooded areas. Permeable pavement was used instead of traditional asphalt in an area studied for 6 years. The result was that no surface runoff was detected, the pavement actually filtered the water as it sunk into the soil, and there were no visible signs of wear on the pavement. Could this be used in Houston on a large-scale project? Rooftop rainwater solutions were also talked about in another article. These systems are being built in areas around the world with problems such as increasing population and development and decreasing areas for water to go. Since urban areas are congested with water, Rooftop systems take some of the stress from drainage pipes. Runoff water was also found in lower qualities because the water did not hit a building and flow off. Rather, it is absorbed in specially designed rooftop mechanisms to reduce flooding and stress on drainage systems. There also, in turn, benefits the groundwater and sewage systems by taking stress off them as well too. Another area of possible solutions lies in the idea of rain gardens. Rain gardens were detailed in this article that looked at ways Greenfield, Pennsylvania could reduce its flooding. Rain gardens alleviate the burden by specially designated gardens that capture water after the rain. In Greenfield and the surrounding areas, one estimate was priced at over $2 billion as an alternative to rain gardens in the sense of sewage control systems. Instead, rain gardens were installed for a cheaper but not exactly detailed price. Greenfield hopes this is the start of green initiatives the city hopes to enact in the coming years, one of which includes a permeable pavement sidewalk. Rain gardens also give way to increased biodiversity with flora such as flowers, grass, and trees. Annually, the rain garden in particular captures 325,000 gallons of water. This seems like a solution for a small city, not in a high-risk area. However, if Houston was trying to lessen the burden by capturing 9 trillion gallons of water, they would need almost 27 million rain gardens around the city. One area of success lies right in our own backyard. Edison High School in Minneapolis underwent a massive green renovation. Some of the improvements included permeable pavement and stormwater reuse systems. Water that hits the ground will be filtered through tiny holes in the pavement rather than creating runoff and overwhelming the city's drains. Stormwater will also be collected in drainages, which will then in turn be used to irrigate the athletic field. The question lies again in, could this work on large-scale areas such as Houston? These are the data layers that I used. The works that I cited throughout my PowerPoint. Thank you for your time.